All right, welcome boys and girls. This is the Unit 1 corrective. So let's go ahead and take a look at what we need to do. We need to find the value of k. So we're talking about that letter right there. Find the value of k that is perpendicular to the line, blah, 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 blah. All right, so what we want to do is we are going to find the current slope for both of these, and then we set the slope equal to an opposite reciprocal. All right, so let's begin with the equation that has k itself. So 6x plus ky minus 5 equal to 0. So I'm minusing the 6x and I'm adding the 5. So ky is negative 6x positive 5. Divide by k. So y is equal to negative 6 over k. X plus 5 over k. So currently the slope of this line is negative 6 over k. All right, let's go ahead and find the slope of the other line. So the other line is x, 3y, 7. And so I'm going to subtract x, subtract 7. So that's going to be 3y, which is negative 1x minus 7, divide by 3, negative 1/3 x, negative 7/3. So currently the slope of this line is negative 1/3. Okay, on to the question that's actually being asked is, what is the value of k such that the blue line is perpendicular to the red line? All right, so what I'm going to do to be perpendicular, that implies that the slope has to be an opposite reciprocal. AKA, I'm going to set this second slope to be a positive 3 over 1, the opposite reciprocal, or i.e. positive 3. So if I can make this the slope of the blue line equal to 3, thus it would be perpendicular. So I have negative 6 over k, and that's going to be equal to 3. Multiply k, divide by 3. K is going to be equal to negative 2. Okay, the domain. Domain is any bad math. All right. Third root is all good. It can take negative numbers. It can take everything. So no bad math is going to come from that. So the only bad math that I potentially see is the bottom zeros. So x minus 1 implies that x is not going to be equal to 0 or positive 1. So the domain itself would be all real numbers, x not equal to 0 or positive 1. Everything but those numbers, it's all good. Okay. Find the solution to the interval. To do this, what you do is you set absolute values equal to positive and negative version of the answer. So I'm taking a look at x plus 1 is equal to 3, and x plus 1 is equal to negative 3. So I have x is equal to 2 and negative 4. Now what I'm going to do is I'm going to put those on a number line, and I'm going to test these intervals. I'll call them interval A, B, and C. Okay? What they do is they exhibit the same behavior as far as, is this good or not good in comparison to the numbers that I plug in. So, give me 1 second. All right, sorry about that. I had to pause the video there for a second. Here we go, back again. So what I'm going to do is I'm going to plug in, for instance, the number 0, and that will test the entire interval of B. So plugging in the number 0, what I see is that'll be 0 plus 1, which is 1. Absolute value is 1. And so that'll leave us with 1 is less than or equal to 3, which is good. That's a good interval right there. Now, if I plug in something like the number 4, okay, which is in interval C, that'll be 4 plus 1, which is 5. Absolute value of 5 is 5. 5 is less than 3, which is not true. So that's not okay. And then plugging in something small, like the number -5. -5 plus 1 is -4. Absolute value of -4 is 4. 4 is less than or equal to 3. Not true. All right, so right now, the only solution would be -4 to 2. And because it is or equal to, that would imply that these are also acceptable. So the good stuff is -4 to 2 inclusive. Okay, find the roots. This is just algebra stuff. So I multiply 3 and 2, so my multiplication number is 6. Positive, which we mean positive, positive, or negative, negative, going to -5. Because this is a complex ABC, I write it as a fraction twice. Simplify, so this is 1x -1. All right, so the factors of this are 3x -2 and 1x -1. And so because we're looking for roots, that is also implied that it is equal to 0. That means x is equal to 2/3 or +1. All right, here we go. Here we have pi over 3, which is right there. So that's 1/2 √3/2. We want the sign. Sign is the y coordinate, so this is going to be √3/2. Here we have -5 pi over 3. So this is -1, 2, 3, 4, 5. This would be our -5 pi over 3. Which again is at 1/2 √3/2. And we're looking for the cosine. The cosine is the x coordinate. Here we are looking for 7 pi over 4. So 1, 2, 3, 4, 5, 6, 7, right there, which is √2/2. Sorry for the bell. -√2/2. Again, this is cosine sine. Tangent is the same thing as saying sine over cosine. So I'm going to take the sine over the cosine. That's obviously equal to 1, but with the sines, that's -1. Negative pi over 3, sorry. Sorry, I'm a busy man right now. So here we go. So negative pi over 3. Negative pi over 3 is right down here. And so that would be 1/2 -√3/2. And so secant is 1 over cosine. So that's going to be 1 over cosine. And so that's going to be 2. 7 pi over 6 is a little bit bigger than 1. So that would be down here, 7 pi over 6, which is -√3/2, -1/2. Cosine is 1 over sine, or excuse me, cosecant is 1 over sine. And so that's 1 over -1/2. And so that's going to be -2. All right, graphing stuff. Here I have an absolute value. This is going to be right 4 down 2. So right 4, 1, 2, 3, 4 down 2. Okay, so that is our start point. And and then everything else goes in perfect V's, put a bunch of dots. Make sure it goes off the graph. All right, let's go to the right. This is a parabola. This is going to be, see, in the last, right 2, up 5, and then upside down. Right 2, up 5, upside down. So right 2, up 5, upside down. So that's going to be 1, 3, 5, 1, 2, 5, 1, 3, 5. I'll come back to the domains and ranges. Here, this is going to be down 3 and then backwards, left and right styling. So down 3 and then 1, 3, 5 going trailing off to I'm going to pause the video for another minute so the morning announcements don't interrupt. All right, back to it. Okay, here we have an x to the third. Again, what an x to the third looks like is it's an up 1 and an up 8 concept, up 1, up 8. So here we go. So this is left 2, down 3. So left 2, down 3. And then, so from this line, it'll be up 1. And then again, from that baseline, again, up 8. So 1, 2, 3, 1, 2. There it is right there. So that is that. Here is our circle. So what we want to do is kind of complete the square. So I'm going to group up the x's. So x squared minus 6x gets grouped up, and then the plus y squared plus 8y gets grouped up, and that's still equal to negative 16. All right, so I'm going to take half squared. So this is going to be negative 3 squared, and this is going to be 4 squared. Now, to make that happen, in the previous step, I have to add what was missing. So in the previous step, I'm missing a 9. So you take half squared, but you have to reverse add the half squared. So that negative 3 squared is positive 9. Like it's going to be positive 16 over here. All right, so again, in the previous step, whatever you do to one side, you have to do to the other. So you have to add 9 and 16. Thus, the step that I'm on, that's going to be equal to 9. All right? So that means that our center is going to be at positive 3, negative 4, with a radius of 3. So we're going to be at 3, negative 4, with a radius of 3. All right, here is the piecewise function. So negative 4 exists from negative 2 backwards. So negative 2 that way, not including the negative 2. So that's that top line right there, open dot. All right, next is going to be a line with a y-intercept of negative 3. And that is going to exist from negative 2 to 0. It has a slope of 1. So that will be that. So that's closed dot. And this is open dot right there. And then I have a parabola, left 1, down 2. So that's going to be 1, 3, 5, 1, 3, 4, 5. Kind of going in that direction, but again, these points don't exist. You have to, this is only going to exist greater than or equal to 0. So starting at the 0 and going this way. So the backwards doesn't exist. That should be your graph right there. If you ever have a open dot that gets filled in by a closed dot later, right? If you ever have an open dot that gets filled by a closed dot later, that dot is ultimately a closed dot. So don't draw like a dot with a circle or something like that. That's nothing, all right? So if you have an open that gets closed, it's officially closed. All right, going backwards, domain and range. So domain is the left and the right. So this goes left forever, right forever. Range is the bottom top. So the bottom is -2, the top goes forever. Domain, again, is left, right. Bottom, there is no bottom. Top is 1, 2, 3, 4, 5. Domain, left, right. Range, bottom, top. Domain, left, right. Range, bottom, top. Wonderful. All right. Mimic this right here. All right, so what I see in this problem is this is going to be left 2, up 2. So this is going to be left 2, up 2. This is what that is going to look like right there. So all the critical dots are left 2, up 2. So left 2, up 2, left 2, up 2, left 2, up 2. I'll come back to the domain and range later. Here, all the y coordinates are going to get multiplied by -2. So this has a y coordinate of 0. So 0 times -2 is still 0. This coordinate right down here is -2. So -2 times -2 is +4. So that relocates up there. The last critical point right here has a coordinate of +1. +1 times -2 is -2, so that relocates down there. This is all right. This is all y coordinates are going to be positive. So what that means is that section of the graph is already positive, so it doesn't do anything. Okay, everything else becomes positive. So here where it dips into the negative zone, it goes to the positive. So for instance, if this has a coordinate of -2, its new coordinate is going to be +2. If this coordinate is -1, it's going to be +1, et cetera, et cetera. So it's going to look like the same thing, but just above the line. Take that. All right, here we go. Let's backfill this with domains and ranges. So of my red picture, the furthest left is 1, 2, 3, 4. Right is 1. Bottom is 0. Top is 3. Okay, left is -2. Right is 3. Bottom is -2, top is 4. Left is -2, right is 3. Bottom is 0, right is 2. All right, right, find the equation of the line. We don't have to graph it. So let's find our slope. So that's y2 minus y1 over x2 minus x1. All right, so for this top, I'm going to see these as 12, excuse me, below the left, no, sixths. So this is still 1/6, and this is 3/6. So right now, this top is going to be -2/6 or -1/3. This bottom is going to be 12ths. Okay, it's going to be 12ths. So this is going to be -9, and this is going to be 8. So this is -1/12. All right, that's so far so good. And then when I divide, I multiply. So this is going to be 12 over 1. And so this is going to be, negatives obviously drop. So this is going to be 24 over 6, or i.e. 4. That's going to be 4. All right, so that is our slope. So our slope that we are using is 4, and pick one of the random points, and I will just select -2 over 3 and 1/2 as the point that I'm using, and then go ahead and write your equation. So y minus y is equal to mx minus x. So this is 4x plus 8/3 plus 1/2. I could probably maybe plan this better. Let's go 6. So plus 3/6. Going backwards right quick, this is going to be what? 16/6. That's 16/6. And thus y is equal to 4x plus 19/6. All right, find an equation and that passes the point, and then sketch the line. All right, so this has 0, 3 with a slope of -2/3. So I make sure I draw the line and then write the equation. 0, 3 is the same thing as a y-intercept. So this has a slope of -2/3 and a y-intercept of 3. So this is going to be y is equal to -2/3 x plus 3. So draw the equation, or excuse me, draw the line and write the equation. Okay, a slope that is undefined, it means this is a vertical line. So that means this is going to be x is equal to. So x is equal to 5 is going to be my vertical line. So I go to where x is 5, or you could go to 5, 2, it doesn't matter. 1, 2, 4, 5. And it's going to be a vertical line. So notice how that vertical line goes through 5, 2 as well. All right, here this has a point of 0, 0 and a slope of 2, or i.e. 2 over 1. So again, this obviously has a slope of 2. This has a y-intercept of 0, so y is equal to 2x plus 0. All right, that's it. Don't know about the weird numbering, but that's how you do this. Thanks for watching.